So a friend of mine said that the world needs more Docker tutorials. You know what? Sure. I know stuff about Docker. Let's make one. So I'm going to go over 4 concepts related to Docker that I kind of struggled with and I couldn't find that many good explanations on. First thing, Docker files depend on each other. When you're first learning about Docker files, you kind of think of it as this Docker file is a recipe that describes everything about how this container works. That's somewhat true, but usually the first line of that Docker file is going to be a from. On real production Docker files, you often find from some other Docker file or some other project that is then based on another Docker file. And so to truly understand everything that's happening in that build process, you need to understand everything in all the Docker files. So a really good example of this is the Jupyter collection of notebooks. I'm just going to pick SciPy notebook. So let's see if we can find the Docker file for this. I'm going to go to their GitHub page. I'm going to search for Docker file. And this looks like it. So we've got some silliness with environment variables going on. We're doing from this base container variable. And this base container variable is from Jupyter minimal notebook. So that's a different image. So let's see if we can find that one. Yep, it's right here in the same repo. Okay, so this one is coming from base notebook. This one is coming from Docker Stacks Foundation. And then finally, we get to the beginning, which is Ubuntu 24.04. Now, this is a pretty neat example because there's a link to the GitHub right on the page of the top level image. And then we come to the GitHub and all of the Docker files are just neatly, nicely organized right there. Unfortunately, you're not always this lucky. So there is actually a more automated way to see all the commands that have been run to create a Docker image. So I'm going to come into a terminal and I'm going to pull this image so that we can take a look at it. Okay, so rather than trying to look through the web of Docker files and figure out what's going on, we can use the Docker history command to give us a list of all the commands in all the Docker files that created this image. And here we go. Some of these are truncated, so you can do, I think it's no trunk. And yeah, that shows the entire commands, but it's weirdly formatted. You can also look at this stuff in the Docker desktop app. We'll go to images, click on this one, and here we have all the different commands that have been run. The next thing I want to cover is how you debug your Docker files when the build doesn't work. So I have an example here. I'm calling it dummy symbol Jupyter Lab. It's just we start from Ubuntu, and I did pretty much the minimal amount of stuff possible to get Jupyter Lab running. Not super important that you understand Jupyter Lab for this. So I've got this Docker file, and now let's try to build it. Docker build. I'm going to use the current directory as context, and we'll call this image video. Oh, geez, what happened? It didn't work. Oh, my gosh. So we were trying to install a bunch of stuff. We can see that it broke on this line, but it doesn't really tell us why. It just says did not complete successfully, exit code 1, and we just see it says abort. I don't know. So in this situation, if we didn't know what we were doing, we might resort to guessing and checking, but we know what we're doing. We're not going to do that. Don't guess and check. So instead, what I usually do in this situation is I want to get a shell in the container at that step and then run this step manually and see what happens, and then maybe try different variations of it and see how we can move forward. So to do that, I'm actually going to comment out everything, including this line and after it in the Docker file. Whoops. And now we're going to come back to the terminal and try that build again. This time, of course, it's going to work because all this stuff already worked. Now let's see what that image is. We can list our images using Docker image list. And we see our video image. So here's the image ID. So I'm going to run a container using this image and then get a bash shell in it so that we can poke around, see what's going on. Docker run -it is for interactive. I'm going to throw that image ID in there, and then bash is our shell. This is the command line we want to start with when we run this image. Cool. So now we're in the container and we're just in the root. So first thing I'm going to do is I'm literally just going to run this command. So copy this, drop it in here, see what happens. And pretty immediately we get our answer. So the reason it failed is because it's asking the user, do you want to continue? Are you sure you want to install all this stuff? But there's no user. It's just an automated Docker file. So it breaks. Many of you might have just seen that. But the important takeaway here is when you're going through these Docker files and you're writing them, you can always go in and introspect just by commenting out the line that broke and everything after it, building a new image, and then just running a shell on that image. So the solution, of course, is to add this -y so that it just says yes to everything and we don't have to intervene. So we'll get out of this, redo the build, and it should work this time. Cool. So the next thing I want to talk about is volumes. You've probably heard of Docker volumes. They're used everywhere, but I feel like they have a reputation of being way more complicated than they actually are. They're super simple. I'm just going to show you a quick example of how I'd add a volume to something. So we've got this Jupyter Lab container, and this is a good example. So I'm going to run it. Jupyter Lab listens on port 8888. So we're going to pass that port through so that I can actually access it. And here we go. This is Jupyter Lab. Docker containers have no persistent storage. And that's really what volumes are for. Sometimes you need to have persistent storage. So like here, if I'm doing work in this Jupyter Lab environment, maybe I make like a stuff folder. I'm going to come here. I'm going to get rid of my container, stop it. Don't need that anymore. I'll just spin up a new one tomorrow. I run a new container. My stuff folder's gone. I can't find it anymore. The way we solve this is, of course, with a volume. You can create a volume using Docker volume create and then the name of your volume. We can use this volume in the container by adding the -v parameter to our Docker run command. So first you put the volume that you want to use, and then you put the path to the folder in the container that you want to be backed by that volume. So here we're backing the /stuff folder in the container with the stuff volume. So now I have this stuff folder here. So now when I delete this container, the volume is still here. So when we launch the container again, we still have our important science file. The last thing I want to talk about is pruning and listing your Docker stuff. If you're familiar with Docker at all, you probably know that it can guzzle a lot of storage. If you're working on something and you're rebuilding frequently, you can easily blow through hundreds of gigabytes. So we really want to remove the old stuff and keep that space under control, especially since if we built something like 10 days ago and it didn't work, we probably don't need it anymore. So first of all, listing stuff. You already saw me do Docker image list. That lists all our images. Similarly, we can do Docker volume list to see our volumes and Docker container list to see containers. So this is that container we just made. It's still running. I'm going to stop it using Docker stop and then the container ID. And now when we do Docker container list, there's nothing. Well, that's kind of weird. So you might think, well, oh, we just stopped it. It's gone, right? So when you stop a container, it doesn't actually get deleted. It just gets stopped. And in order to see all the containers, including stopped ones, you need to use -a on this Docker container list command. So now we see that stopped container here. And that will become important when we start talking about the Docker prune command. So Docker prune has a bunch of variants, like Docker image prune is a common one. This will get rid of all dangling images, which means images that are not tagged and that aren't used by a container. So I'm going to say yes to this, and then we can see what that means. It only deleted one. But if we do Docker image list again, BusyBox, I don't remember that. Anyway, we see that these are all tagged, and video is the one that's being used by our container. But let's say that we decided to make a change to this. We wanted to add CMatrix so that we can enter the matrix. After we rebuild, if we do Docker image list again, you're going to see this none thing, and there's no tag. And this is actually our old version of that video image. Since we created a new one, it moved the latest tag to the newest image, and this one is just kind of like chilling here, not doing anything. And that is exactly what Docker image prune is going to get rid of. That's the dangling image. Oh, right. Okay. This one is still being used by the container. So if we do Docker container prune and we remove the stop container, then we can do Docker image prune again. And that should remove this image. So at this point, you might be thinking, well, if this is really complicated, I'm not going to remember all this. There should just be one command to do everything and just get rid of all the stuff. And there is. It's docker system prune -a. So I just ran this command before starting filming, and you can already see we've gotten 6 GB back. So when I'm doing this at work, I frequently see like 200-300 GB. Unfortunately, there's a little bit more, because if we do Docker volume list, that volume is still there. If you also want to get rid of all your volumes, then you can do Docker volume prune -a, and that will get rid of all your volumes that aren't hooked to a container. And that really, for real, finally, for sure, should be everything. Thanks for watching. If you've got any video ideas for me, please leave them in the comments. I especially want to do stuff related to AI, because I'm interested in AI, as basically everyone is. If you're interested in AI, you should subscribe. My dream is to hit 1 subscriber. And if you could help make that possible, it would mean so much to me. Also, don't forget to destroy the like button. And speaking of destroying things, I was going to use the infamous dependency XKCD comic as part of this video, but after I wrote the script, it didn't really fit in. Unfortunately, I already took the liberty of recreating it in Blender. So we'll end with this footage of all modern digital infrastructure getting destroyed. Goodbye.